Hi everyone, in this video I'm going to be explaining to you the working of analog quantities, how they are being read using the Arduino microcontroller. Okay, so for that we have dedicated 6 analog pins available on the microcontroller. We will be looking at how they are working. In addition to the specific functions listed below, the analog input pins support 10-bit analog to digital conversion. So this particular analog pin has a 10-bit analog to digital conversion. The microcontroller is only able to understand digital values 0 and 1. The real world outside will provide you values that are not digital in nature, that is changing discretely from time, not discretely from time to time. So you need a converter over there that is going to convert that analog signal into a digital signal. And for that you have a 10-bit analog to digital converter ADC, and that is being used in the analog read function. So when you give an analog read function in your particular microcontroller program, Arduino program, you should understand that it is a analog to digital converter that is being used over there, and that is a 10-bit analog to digital converter. Most of the analog inputs can also be used as digital pins. Okay, so as I told you in Arduino microcontroller, analog pins can be declared as digital pins also, input pins also, but it cannot. It is not for all microcontrollers. Specific microcontrollers like Nano and all, they have pin number 6 and 7 dedicated only for analog purpose. Analog input 0 and digital pin 14 through analog inputs 5 as digital pin 19. Okay, so these are the particular values over here. So totally they are digital, 19 pins available, 14 pins of 0 to 13 and 5 another analog pins over here. So totally you have 19 pins. Analog input 6 and 7 present in the mini and DT cannot be used as digital pins. So this is what we saw earlier. Okay, and this is the syntax. This is the statement that is being used for reading an analog signal. You will not have an analog write. Please remember, your microcontroller can only read data from the outside world. It cannot write a value of an analog signal to the outside world. So you will only have an analog read over here. This reads the value from the specified analog pin over here. That is what it is going to do. From the analog pin, it will read the particular value, and the Arduino board contains a multi-channel 10-bit analog to digital converter. So it has a multi-channel. So you have 5, 6 dedicated pins over there. So separate channels for each pin. So separate 10-bit A to D converters are available over there. This means that it will map input voltages between 0 to the high voltage 5 to 0.35 volt between the value 0 to 123. 1023. So 10 bit 2 power 10, 1023 over here. Sorry, 1024. So it will be 0 to 1023 n minus 1023. So this 0 to this particular 5 volt or the 0 to 3.3 volt is mapped accordingly to the range 0 to 1023. So what is happening from the real world? If I get a value of 1023, it means that it is either 5 volt or 3.3 volt. If I'm getting a value, for example, 0, it means that it is a 0 volt in the case. Half of this value could be half of the power supply voltage over here. That is how they are mapping the two values of digital and analog signals using this particular analog read over here. On an Arduino Uno, for example, this yields a resolution between 5 volt per 1024, that is 0.0049. So each step in my analog to digital conversion, 0 means 0. So what is the 1 over here represent? So 1 represents 0.0049, and what is 2 represent over here? Double this value, 0.0098, and so on. So 0.0098 plus 0.49 is going to be the value for 3, and so on. So what is it going to be? 4.9 millivolt per unit. So 4.9 into 1023 is the value that you'll be getting as the total voltage over here. That is the concept that is explained. Okay. The input range can be changed using the analog reference value. So if you want to change the range of your particular input value, instead of 0 to 2023, if you want to change it, you can use the syntax of analog reference, while the resolution can be changed only for 0 due and MKR boards. This can be only done using the 0 due and the MKR boards using analog read resolution. Okay, normal one is the analog reference, but the resolution can only be changed using the two boards using the syntax analog read resolution. On Atmega based boards Uno, Nano, Mini, Mega, it takes about 100 milliseconds to read an analog input. So the maximum reading rate is about 10,000 times a second. Okay. So that you have to write your program accordingly and you have to give the corresponding delay in your program such that the data is read accordingly. So the syntax over here, as I told you, it is only going to get input from the outside world. So it is going to be just the pin and not the value over here, pin comma value. So the statement used for that is the analog read of pin. So what are the parameters? We saw that pin over here. You have pins from A0 to A5 for your Uno boards. You have A0 to A6 for the NK boards. A0 to A7 for Mini and Nano. And for Mega, you have double the number of analog pins. So you have A0 to A15 for this particular Mega over here. So you will be either specifying A0, A1, A2, A3, A4, A5, A6. Either of those values will be specified in this pin over here, whichever pin you connected it to. Next, you will return the value. What does it return? The analog reading of the pin, whatever it is over there, although it is limited to the resolution of analog to digital converter 0 to 1023 for 10 bits, or if you have a A to D converter of 12 bits, it is restricted to 0 to 4095. Okay, so 4096 is 2 power 12, so it is restricted to that particular value here. So 2 power 11 is 2048 and so on. And what is the data type over here? It is an integer data type. An example code for this particular Arduino is given over here, and this particular example reads the voltage on the analog pin and displays it. And we are going to display that on the serial monitor of your Arduino IDE. So on the Arduino tool, you will be having on the top right corner an option which looks like a symbol of a lens. When you click it, you will be getting an additional window opening over there, and that window is what you call as the serial monitor. So whatever voltage is being read by the analog pin is being displayed over there using that. Okay, so that is what we're going to see for now. And these particular program is going to explain the working of that particular concept over here. So look, we'll see we are connecting the particular pin of my Arduino to pin number A3. Okay, so as I told you, I am declaring the pin A3 to a variable analog pin. This we had done earlier in the digital program. Similarly, we are doing this in this analog program over here, where A3, pin number A3 is assigned to a variable analog pin over here. Okay, so whatever value is available on A3 will be available on the variable analog pin over here. So that is what you're going to see. And I'm initializing this value to be equivalent to 0. So initializing this value to be 0. Then I'm going to communicate this data to the serial monitor. So when I'm communicating it to the serial monitor, I will be using this instruction over here called the serial begin. So the serial begin of 9600 means this 9600 represents the baud rate or the bits per second transmission rate. Okay. So from the Arduino to the serial monitor, the data is transferred in this particular bit rate of 9600. On the serial monitor at the bottom right corner, you will have, or you will also have the option of baud rate over there. Make sure that the baud rate over there is also at 9600. And what is happening next? This is a one-time execution. The initialization process has taken place over here. From the pin A3, I'm going to move the value to this particular serial monitor. So the variable used for that is value. So what am I going to do? From the analog pin, I'm going to read the value and put it in value variable over here. So I'm going to do that. I'm going to analog read the value of analog pin, that is pin number A3, and I'm going to store it in the variable value over here. That is what I'm doing in this program. Later, what am I going to do? I'm going to print it on the serial monitor. So I'm going to use the syntax serial print value. So to print that particular value, I'll be using the syntax serial print over here. If I give serial print, it will be executed on the same line. If, for example, the first value is 3.3 volt, then the next value of 3.4, for example, will be adjacent to it. So if I want it to be displayed one line after the other, in C programming, you'll be giving /n. Similar case over here, you'll be giving ln. That is the difference. So serial print ln, it means the values will be displayed one line after the other over here. Okay. So with the baud rate of 9600, you will be printing the values one line after the other using the serial print ln over here. I hope you're able to understand what is happening in this analog read. We also saw the digital read. We also are now seeing the analog read over here. So you see that one variable was declared over here, and you are taking the input from A3 and you're storing it in a particular value over here, and you are displaying it on the serial monitor. You do not require any additional output devices to display this particular thing. So next is my analog write over here. So description writes an analog value PWM to wave to a particular pin, and this can be used to light a LED or varying the brightness of a drive or motor. So LED brightness can be varied over here, or you can even drive a particular motor with various speeds over here. A normal motor, if you are using it in digital, you will either have on or off condition only. But if you want to vary the speed, as in the case of your particular fan, you can use this particular analog write signal over here. Okay, you cannot use a digital write over here, you will have to use this analog write over here. After a call to the analog write, the pin will generate a steady rectangular wave of the specified duty cycle. So the on time, off time, this specification forms a particular cycle. The on time of that cycle is what I call as a particular duty cycle. Okay, until the next call to the analog write, or call to the digital read or digital write on the same pin. So please remember, the rectangular wave is being generated when you have an analog write over here, and that analog write is having uh, a rectangular wave. That rectangular wave has a duty cycle. The duty cycle, it will look like a clock pulse if it has a duty cycle of 50%. So 50% on time, 50% off time over here. This is what you mean by a particular duty cycle. So the syntax for that is analog write pin and what is the value. So pin should be specified and what value is to be specified is specified over there. So we look into what is that pin, the Arduino pin to write to. So which particular pin you're writing it to is specified over there, and you are using integer data type only can be used over there. And the duty cycle that you are going to use can vary from a value 0 to 255. Okay. So 0 means always off, it will be always 0, and 1 means it will be always on over there. That is the case over here. And this is the example code for that. This sets the output to the LED proportional to the read value from the potentiometer. Okay. So from a potentiometer, I am going to read a particular value, and according to the potentiometer value, I am going to vary the brightness of my particular LED. That is this code. Okay. So what is happening over here? I need to declare my LED pin to a particular pin number. That is a digital pin. I need to read the data from my potentiometer through a particular pin, and that is my analog pin over here. Then I have my value variable equal to 0, which is reading the value from my particular analog pin and putting it into the LED pin over here. So what is going to be declared over here? As I told you, you are declaring this particular LED pin to pin number 9 over here. So what is happening? LED pin comma output. 9 is my particular output, which is my LED. So pin mode, that is being declared over here. So one time execution is over and initialization part is also over. What is my next step over here? I'm going to declare it in the loop. What am I going to do? I'm going to read the value, analog read the value of what? My particular analog pin, which is my potentiometer. So that is going to be read over here, and that is stored in the variable value over here. Okay, so it is stored in the variable value over here. And what is happening next? I have analog write, and what am I going to do? Please remember, it is not digital write, it is analog write over here, because it is a value that is going to be changing from 0 to 255, or it is going to change from 0 to 1023. Okay, and so this value depends on the potentiometer value. So that value is being put on the LED pin over here. I'm not exactly putting the same value on the LED pin. I'm just dividing it by 4 and I'm putting it on the LED pin over here. So whatever value I'm getting on the potentiometer, that value I'm going to divide it by 4, and I'm putting it on the LED pin as my brightness value over here. So my potential as why is this 0 to 1023 here? Because I have a 10-bit A to D converter. So 10-bit A to D converter is 0 to 1023, but the value that can be displayed on my LED is only 0 to 255. So what I need to do is I need to divide that value by 4. So 1024 divided by 4 is equal to 256. So I'm going to divide that value by 4. So I will be getting now a value which is in the range 0 to 255. For example, if I have 1023, it will be now 255 over here. So that is the case. So that is why I'm having the value by 4 and I'm putting that on the LED pin output over here. So accordingly, my brightness of my particular LED is going to vary. So I hope you are able to understand this particular concept. Thank you.